A dog lay down beside a hospital bed in Oregon and refused to move. No one told him to. No one trained him to. The nurses had seen him do this before, with other patients, in other rooms. Always the same pattern, always a few hours before the end. The family called it a coincidence the first time. By the third time, they stopped calling it anything at all. Most people assume animals live entirely in the present, that they cannot sense what is coming, only what has already arrived. A threat you can smell, a sound you can hear, a movement you can see. That's not what the evidence shows. Something in certain animals appears to detect death before it happens, not after, not during, but before. And the closer scientists look, the stranger the pattern becomes. This isn't a story about ghosts or intuition or anything mystical. It's a story about chemistry and about a sense so old, so buried beneath our own five, that most humans have forgotten it exists in anyone at all. To understand what is happening in that Oregon hospital room, you have to look at what happens to a biological body when it prepares to stop. Every dying human body begins releasing a specific cocktail of volatile organic compounds. Chemical signatures produced as cells break down, as metabolic pathways alter, and as organ systems begin to fail, one by one. This isn't speculation. Hospice researchers and biochemists have documented it in precision detail. It happens quietly, invisibly, days or even weeks before a heartbeat stops. Polyamines like putrescine and cadaverine begin to form in micro amounts long before clinical death. Shifts in breath composition, sweat glands, and skin lipids broadcast an invisible chemical alarm. Humans cannot detect it. Our noses were never built for this. But a dog's olfactory system contains up to 300 million scent receptors, compared to roughly 6 million in ours. The part of a dog's brain devoted to analyzing smell is, proportionally, 40 times larger than a human's. What we call instinct may simply be a nose reading a complex biological language we never learned to speak. Which raises an uncomfortable question. If a dog can smell the chemistry of dying, what else can? In 2010, researchers studying a nursing home in Rhode Island documented something that made headlines around the world. A cat named Oscar, living quietly among elderly dementia patients, had developed an unsettling routine. He would walk down the hallway, enter a specific patient's room, curl up on the bed beside them, and within 2 to 4 hours, that patient would pass away. Staff began to notice the pattern before the families did. Oscar had predicted more than 25 deaths with what looked, from the outside, like calm, unwavering certainty. He showed no interest in patients who were merely sick or sleeping. He never stayed in the wrong room. If he was shut out of a room where someone was about to die, he would scratch at the door and meow insistently until they let him in. The staff started calling family members the moment Oscar walked into a room, not because they believed in anything supernatural, because he was right more often than the medical monitors were. Doctors hypothesized that Oscar was responding to specific ketones or volatile acids released by dying cells, combined with the total immobility of the patient. The cat wasn't acting as a harbinger of death. He was simply drawn to a faint, unique environmental scent that signaled a profound change in the room's atmosphere. Here is where the story could stop. As a curiosity, a strange footnote about pets in nursing homes. But the deeper you look, the further the pattern extends beyond the walls of hospitals and into the wild itself. In the wild, death is not hidden behind white curtains or muted digital alarms. It is the central engine of ecosystems. Elephants have been observed returning, years later, to the exact location where a family member died. They do not pause for other bones scattered across the savanna. They stop specifically at the bones of their own species, touching the weathered skulls gently with their trunks, passing them along, standing in absolute silence for hours, in a manner researchers still hesitate to fully explain. Whales have been recorded supporting the bodies of dead calves at the ocean's surface for days at a time, swimming thousands of miles without eating, refusing to let the small bodies sink into the depths in what looks disturbingly close to grief. Crows gather in silence around their dead, not to feed, but to observe, in a structured event some ornithologists now call a funeral. Carefully, almost reluctantly, because using that word implies something we aren't sure animals are supposed to possess. None of this proves that wild animals sense a human's death specifically, but it proves something far more unsettling, that the boundary between animal instinct and what we quietly call human awareness is not where we assumed it was. There's a theory that ties all of this together, and it isn't about mysticism, it's about evolution. For most of animal history, detecting death early wasn't a curiosity, it was survival. A predator that could sense a dying, weakened animal miles away gained an easier kill with minimal risk of injury. A scavenger that could read the faint chemical plumes drifting downwind secured vital calories before competitors arrived. Conversely, a social herd that could sense death approaching one of its own could prepare, reposition, or protect the collective group from passing infections or lurking predators. The ability to read the chemistry, the breath, the micro-movements, the subtle drop in body temperature of an organism approaching its end. This wasn't a gift. It was a primary tool, sharpened over hundreds of millions of years by the simple fact that animals who missed the signal often didn't survive to pass on their genes. Humans lost most of this. We built shelter, fire, agriculture, and medicine. We stopped needing to smell death coming in the wild because we built sterile rooms and diagnostic equipment to manage it for us instead. We traded our primal chemical receptors for abstract thought, written language, and tools. But the animals living closest to us, the ones who never fully left the wild behind, despite generations of domestication, may have kept the ancient sensory hardware we gave up. This is the part where the story turns uncomfortable, because if a dog or a cat can smell the compounds of a body shutting down, organ by organ, days in advance, then in some very literal, chemical sense, an animal in your home may already know something about your body that you don't. They aren't reading the future. They are reading the immediate chemical present, a present that human technology requires blood panels, MRIs, and biopsies to detect. Hospice nurses have learned to read certain pets the way they'd read a heart rate monitor, not because the animals are magical, because the animals are honest, reacting to an undeniable biological signal, completely free from the social conditioning that makes humans deny what they see coming. We spend our whole lives training ourselves not to notice death approaching. Denial is, in many ways, a distinctly human skill. We distract ourselves. We look at charts. We hope against logic. The animals never learned how to deny what their senses tell them. There's no real comfort in the ending of this story, And perhaps there shouldn't be. Somewhere right now, in a quiet, dimly lit room, a dog may be lying down beside someone he loves, not because he was told to, not because he understands medical diagnoses, hospitals, or the concept of time, but because his body is reading a signal that has existed for longer than language, longer than medicine, longer than the species standing beside him. He isn't guessing. He's remembering something we forgot how to notice about ourselves.